My name is Mike Fratto, Senior Analyst with 451 Research, and I cover enterprise and cloud networking. Over the years, the load balancer and application delivery market has evolved, with vendors adding more capabilities to their products. For example, there have been a number of security capabilities added for authentication, authorization, and access control. Vendors have added web application firewall capabilities and other filtering capabilities to their load balancers and ADCs in order to take some of the security requirements off of the applications themselves. And there have been a number of enhancements in the load balancing algorithms and the decision making on when to perform a load balance and when to add more application. Another shift has been in licensing, where load balancers and ADCs used to be based mostly on hardware, and they were licensed on hardware at a fixed capacity. Now, with the software focus of load balancers and ADCs, we're seeing many more products having a consumption-based model, which allows IT to align their spend to their use and to make more effective use of their licenses, and which are more versatile and work better in a cloud context. And there have been a number of capabilities added to support DevOps, or the combination of developers and operations, into a new management scheme, supporting APIs and SDKs, allowing application developers and operations to integrate the load balancer and ADC into application deployment management frameworks and CI/CD frameworks. While there's been a number of enhancements to application delivery controllers and to load balancers, making them more feature-rich and more capable, there's been a shift in the buying center or the buying influencer for load balancers and application delivery controllers. Where it used to be IT operations, more and more the application architect and the application developers are involved in the buying process and making recommendations. So with application developers and application architects, they're typically writing the code in the environment it's going to run in, whether it's a cloud service on premises or a cloud service that's like AWS or Microsoft Azure. So they may use the native load balancing services that are in those cloud services, or they may use an open source load balancer. So for the application developer, their expectations are it's good enough, and they write the application within that kind of environment. And that's fine during the development process. But when that application moves into production, oftentimes issues around scaling and the mobility of the application from one service to another, and other requirements that the application has to meet simply won't be met with these rather basic but functional load balancing services. So you need to move to more advanced features and functionality that fits the application better and allows IT and developers to customize that application. Cloud native architectures are also driving changes in the application lifecycle. So as an application scales up and scales down based on demand or moves from one cloud service to another, that load balancer and ADC needs to be portable as it moves, as the application moves from service to service. Of course, as vendors have added more functionality and more capability to the load balancer and ADCs, they've become more complex to manage, to operate, and to integrate into other management software and automation systems. And so we don't want to move to a point where the software becomes so complex to manage, but we don't want it to be so simple that it's not feature rich. So it's about finding a balance between these two extremes that work for your particular requirements. There are two primary ways that enterprises are deploying load balancers. Traditionally, there's been one load balancer with multiple applications running on it. And in that environment, there might have been more or less separation between the applications that were running on the load balancer. But this allowed companies to reuse that hardware and to multiplex those applications, but it made configuration much more complex because a configuration on one application could impact the configuration and performance on another application. And as applications would move from one location to another, it became very difficult to move that application and its load balancer and ADC configuration along with that application. It had to be prepared in advance, and then the application had to show up over in that other service. The other model that enterprises use, and this makes a lot more sense in a cloud native type of model that we're seeing today for applications, is one ADC per application. And this allows IT to customize that load balancer for a particular application. And it's coupled with the application into a complete package so that it can be moved from one location, like an on-premises data center, out to a cloud service or out to multiple cloud services. And then any impact to that load balancer is limited to just that load balancer. So it actually increases the reliability of the application environment as a whole. There are a number of questions that enterprises should be asking when they're assessing a load balancer. In a hybrid cloud, multi-cloud world, where applications can be running in multiple cloud services, in a hybrid cloud or in a multi-cloud world, you might have applications running in different cloud services, and they may be serving specific regions of the globe or specific regions of your country. Functionality like global server load balancing becomes fairly important because it allows enterprises to direct users to the closest application or the closest instance of an application, regardless of where they're coming from. And this doesn't have to be across the globe. It could be within a region or within a country. And you'll find yourself using global server load balancing actually quite often as you're deploying across cloud services and as you're creating a highly available application. There's portability of the load balancer. Again, in the multi-cloud and hybrid cloud world where most enterprises are heading with their applications, being able to take the same product and move it into different environments is very important. And typically this involves licensing support from the cloud service, certainly the environmental support and the runtime support within a cloud service, and the ability to deploy and update the software within that cloud service. So being able to port that application along with a load balancer becomes a critical capability. There's operational consistency. Having the same software running in all of these environments, in cloud services as well as on-premises, just allows IT to gain experience and knowledge with that product and to apply it wherever that product happens to run. So it becomes more operationally efficient and you're able to make better use of the software regardless of where it's running. And then there's performance questions, particularly with a soft-based load balancer and application delivery controller running in a virtualized environment, being assured that it will provide the capacity required for the particular application, that you'll be able to scale the load balancer in and out as capacity demands change over time, and the ability to support encryption, which is becoming much more common, and the ability to support, more importantly, the advanced encryption techniques that are going to add additional load, such as TLS 1.3 with the new keying algorithms and the new encryption requirements. So these are just some of the more critical questions to ask your load balancer vendor, your application developers, and the stakeholders when you're evaluating load balancers.